Okay, volume of pyramids and cones. These are the formulas that my brain refuses to remember. So I get thankful for reference sheet, for the internet. I can look them up. I felt terrible because the 7th graders, they've already done surface area and volume. And like a dummy, I put find the volume of this shape on one of their tests and it was a pyramid. And so they did it, but there's something with the formula that they didn't know, so they all got it wrong, and then they felt terrible. But don't worry, I fixed their tests. Okay, Ellie pointed something out. I'm so glad she pointed it out. See the cone over there? Remember my question that I was just like, I can't think of an example when it's not a right cone? What do you think about that? Is that a right cone? Ah, it's not even that bad, right? So it's just tilted a little bit. But do we agree that's still a cone? Yeah, looks like it's still a cone. Okay, so the very first part, the formulas? Right off the bat, we get the formulas down. Okay, there they are. Volume of a pyramid. Here's what I'm admitting. I never remember to do this. The 1/3 base area times height. Pyramids, they're okay to solve for as far as volume goes. Volume of cones, they're easy as long as you figure out, as long as you remember the formula. Don't forget this 1/3 right there. It's still the same formula, 1/3 base area times height, but in a cone, what's the shape of the base? It's a circle, so that's where the pi r squared comes from, because that's area of a circle. Please write that in your notes so it makes sense. Area of a circle is just this part, capital B. Okay, we're just going to use these formulas. Are you ready? Again, pyramid, okay, cone's not too bad to solve for. I think the first example. Of course. Okay, what I do like about this example is it comes up later, so pay attention. Okay, let's think about this. Her question was, how come it's 1/3 for pyramids, 1/3 for cones, and how come not other shapes? Okay, hold your pretend cylinders again. If you take your cylinder and you cut into a cone, what do you think? Is it logical that we're taking off so much of it? It's like we're only using 1/3 of it? Because you're shaving it that much? It's kind of the same with the pyramid. You're taking off pieces of the sides because it's slanted to the top. Yeah, it's like 2/3 is gone. It's a great question. Okay, here we go. Don't let me forget. It's the 1/3, right? So volume is 1/3, capital B, H. Okay, well, one part of this is really easy. What's height of this pyramid? I kind of covered it. Okay, so we know it's 1/3 times something times 10. Okay, we have to find the base area. Dang it, what shape is that base area? Okay, if you have room in your margins, let's just redraw it because that's a little bit teeny tiny to redo. Okay, hexagon. Can I do this? 1, 2, 3, 4, 5. I feel pretty good about that. Hexagon. All right. From the example, what's the length of one of the sides? 4. And then does it say in the directions? Oh, it has a regular base. So if this is 4, what's this one? 4, 4, 4, all the way around, right? Okay, to find the area of this, you've got to go back to chapter 11 stuff. Chapter 11 stuff, we talked about this formula. Area equals 1/2 little AP. Do you remember what the little a stands for? Apothem. Do you remember what the capital P stands for? Perimeter. Okay, so redraw in here. Right here is going to be your apothem. Perimeter, we can do that right now. What's the perimeter of this shape? Yeah, 4 times 6, so just 24. So at least that much is done. Okay. Right here, the apothem is always 90 degrees to one of the sides. Let's draw in a triangle. Take formulas. I feel like you guys are way better than me at remembering formulas. I'm a logical person. And I know there's formulas, but I can't remember which one to use. We need to know what this angle right there equals. Or we need to know what this top angle equals. Does anybody have a plan to figure out one of those angles? What's your plan, Ellie?
So on the center angle, you can figure it out by doing all, because there's, if you do from there to all the vertices, there would be 6.
Mm-hmm.
So you would do, and then it goes around in circles, so it'd be 360 divided by 6.
Nice. All right, so Ellie's plan is to find the top one, 360 divided by 6. And then cut it in half because that would go from a vertex, right? Okay. Divide that by 2. What is it, guys? 30? I thought I heard someone say 36. Do we agree that's 30? If that's 30, what's this one? Check it. We can use our reference sheets. 30, 60, 90 triangle. I think Okay, so if this is 30, that's 60. What is this length of the triangle? Okay, that's 2 inches. Okay, that's across from the 30. Do you know what the apothem would be then? Yay! 2 squares of 3. Good job. So we're just going to stick in my formula over here. 2 squares of 3. And then don't forget to also times it by half. I'm getting way crowded over here. There's 1/2 times 2 squared of 3 times 24. Again, I tried to tell you on the warm-up, be careful because your calculators will pull up a parenthesis right here. What's something really safe to do? Close that parenthesis. So your calculator knows to do that. Well, alright, I want to see how everybody's typing this in. Type in 1/2 times 2 squared of 3 times 24. So I'll check each other. 42.6, we got Christian up on that. 41.6. 41.6, we feel better about 41.6. Okay. So what we just found was the base area. So I'm going to come back up here to our original volume formula. You guys type this in your calculators. Question, how are you handling 1/3? What are you doing typing 1/3? I heard ABC button, that would work. 1 ABC 3. Or just divide, you can do 1 divided by 3 times 41.6 times 10. 38.67. How many grade Christian again? About the same. Thank you for trying out on your calculators. Appreciate it. Okay, keep this hexagon in mind. Once you know the angles in a hexagon, you can just keep going with it. Alright, so final answer. Guys, you did pretty dang good. I'm curious, how many of you, I think I followed that. You followed that? It's gonna come up again. Try it again. Oh good, cones! Alright. So volume formula, make sure you do this right, is 1/3 capital BH, right? So capital B would be pi r squared times h. Okay, so we'll have V equals 1/3 times pi. What's radius in this one? 9.5, but don't forget to do what to the radius?
Square.
Don't forget to square it, it's a big deal. And then height in this one is just straight up. Okay, type it in, guys, literally practice with your calculators. Let's see if we agree, so type it all in your calculator. Okay, tell your neighbor. Show them your calculator, show them what you wrote down. Check with your neighbors. Okay, can I get a hand in there? Will you help me with the decimal? What is this one? Actually, can I call on someone? Are you ready? Okay, let's go with James. James, what did you guys get for this? 505.4 with pi, in terms of pi. Do you have the decimal too?
Yeah,
1587.8. Both of these would be millimeters cubed. Whoa. How many of you got same as James's group? We agree? Okay, try letter B with your neighbor. Go for it, go for it. Alright guys, check the board. Did you get the same thing for volume?
Yes.
I had to round pi. Let me see how many of you got the same thing for volume. You know okay with cones? Okay, let's do another one. Ah, pyramid. Here we go. Alright, it's still the same. So volume equals 1/3 capital BH, right? What's the height in this one? Alright, so we know height is 15, so we'll have 1/3 times something times 15. This shape, what shape is it? Okay, we already did all the background work, so just redraw your hexagon. 1, 2, 3, 4, 5, 6. Okay, do you remember? The apothem down creates a right triangle. Do you remember what angle this was? Yes. What about the top angle? 30. Look at your picture. What's the length of this? Agreed, agreed. That's 4.5. If that piece is 4.5, what's your apothem? Look at that shortcut on this. 4.5 squared to 3. perimeter is 54. Where'd you get 54? Nice. 9 times 6 will give us perimeter. So base area, let's do 1/2 times 4.5 squared root of 3 times, you said the perimeter, was 54. And be careful, I know I'm standing in the way, I'll get it all the way. Make sure you put parentheses around that. 210.5, that was insanely fast. Does anybody agree with 210.5? Jane agrees. We agree, Kyle agrees. Alright, so base area 210.5. Wait. Do we agree? We good? Okay, well let's just take this and put it right there. And that'll give us 5. I don't know how, well I do know how, but you guys did that insanely fast. Okay, type it in. 1/3 times 210.5 times 15. Stop! Check it. Mental math. Do you know what 1/3 of 15 is? 5. So you can just take your calculators and hit times by 5. That'll give you volume. 1052.5. Does anybody agree with that volume? We good? Close enough? And that would be centimeters cubed. If that was insanely fast. How many of you, I get that one, I get that one, I get that one. Hexagons, you okay? Wow. Wow. Okay, let's look at the next one. Okay. Number 2, something's trying to trick you on number 2. Yep. Okay, it's 1/3 base times height, but the base is a circle. So pi r squared h. What does h stand for? Height. Did they give us the height? Do you know the height though?
8.
Wow, why is it 8? Good job.
Because 10 squared minus 6 squared equals 8.
Perfect. It totally solves Pythagorean theorem. It's a good one to memorize. I keep trying to tell you. Okay, so the height is 8. Now we can use our formula. 1/3 times pi times radius is 6 squared times height, you said was 8. 36 divided by 3 is 12. 12 times 8 is something. I already confessed.
96.
96. So if we wanted to, we could just do 96 pi. Feet cubed. Did anybody else get 96 pi? Did I get that right in my head? Does somebody have a decimal that you could just tell us what it is? McCall, what is it?
301.6.
301.6. How many of you, I've got that, even though I tried to trick you, you okay with that one? Okay, you're doing great. Let's do this last one. This one, backwards problem. What kind of problem? Backwards. It's not too bad though, because you can use your calculators. So right here they gave you the volume. What's the volume?
135.
Okay, so let's put 135 equals 1/3 times pi times, did they give us the radius? Oh, it's x. I'm not going to use x because that's going to get confusing because I already wrote an x for time. I'm just going to put r squared. Times, did they give us the height? Did I see it? 8. Just start working backwards. They're all getting times, right? So to get rid of the times, the inverse operation is divide. So take your 135 and start dividing. I would do 135. It doesn't matter where you start. Maybe 135 divided by 8. So that's gone. What would you divide by next? Sure, I'd probably do pi next. So then do divide by pi. So that takes care of that one. How are you going to get rid of the 1/3? Good job, Calvin. Next, times by 3 to get rid of the 1/3. Okay, I'm going to need to stop here and get your help. Does anybody have 135 divided by 8 divided by pi times by 3? Christian, what is it? 16.1. So now we're at 16.1 equals radius squared. What do we do now?
Square root it. Square root it.
Which is about what?
4.
Yeah. And I think it's like insanely close, isn't it?
Yeah.
So why don't we put r is about 4 so they don't think we literally think it's 4? See? Not too bad. Do you agree with me? Just work with our calculators. Okay.